Okay, should I start?
Yes, please.
Yeah.
Okay. Hello, everyone. My name is Vladimir, and today we're talking about is it safe to combine mobile CI/CD solutions and external app protection services based on cloud as well. So I want to start with a story. So several months ago, uh, a lot of contacts, like phone numbers and names, were stolen on the China mobile market. And how it happened? A framework called SW Analytics was infected with a context stealing functionality. So basically, when the application was using this framework and was running on the device, this framework will access the contacts, grab them, send them to the remote server, and stealing them that way. Approximately 12 applications were using that framework at that time, and it affected like more than 100 millions of users in China. And this means that approximately a third of the contacts of the whole China population was compromised. And this is a horrible impact. Okay, so my name is Vladimir Ivanov. I'm an author of Architecture Weekly newsletter in the form of newsletter and a YouTube channel. I spent more than 10 years of doing mobile development, starting with native Android and ending up with React Native, Flutter, and other cross-platform frameworks, and solution architecture, basically designing systems. I also work as a senior engineering manager for Bolt. However, this talk is based on my prior to Bolt experience and on the article that I wrote a couple of months ago in my blog about this, cloud CI/CD and app protection tools thing. So yeah, let's move on. So why do we use mobile CI/CD solutions in the first place? And let's take it from the development perspectives. So we as developers, we're doing a lot of tasks, right? So we're writing the code, then we submit pull requests, then we expect those requests to be merged into develop or main branch. Then we want to run the tests. We want to obtain test reports. We want our application to be deployed. We wanted to release it, right? We want to receive notifications about our build being completed, and knowing the status, obtaining the test report, and so on. And we also want to have issue track integration. For example, if we're working on a feature, we obviously have a ticket in Trello or in Jira or in whatever system you use, and we want to see that, hey, those are the pull requests for this particular task, or like the builds for this task, and like the builds are green, and thus the task can be closed. And those are all our needs. And in order to support them manually, like it is too hard. So we want some kind of a software to help us with all of those. And aside of that, we also want to work in parallel because we want to go really fast, right? So in current fast-paced environment, we want to ship features fast, like not spending on the feature more than a week or two. We want to have releases each week or two. We want to be able to ship several features in parallel so that like our velocity is very high, our time to market is very short. We're able to to ship new functionality and get feedback really fast. So that's great, right? So this kind of environment is really challenging, but also fun. Um, but we don't only want to ship the features; we want them to ship with a high quality, right? Because if it's not, then our users are not happy. Then why we work in the first place? And in order to grant this quality, we write unit tests, we write integration tests, we do some manual testing, we do performance testing, and so on and so on. So we also expect our CI/CD solution to allow us to go fast, but also go with a very high bar of the quality. So why cloud CI/CD is in the first place, right? Because you can tell me, hey, you just can install a Jenkins locally and try to run all those tasks there and like write all the integrations, notifications, and so on inside. However, uh, like it is a piece of work, right? So first of all, you need dedicated hardware because like you can build an Android application on any Linux machine or Windows machine. However, if you're building iOS applications, then you need a Mac Mini or a MacBook or other Mac hardware that you can run Xcode and Xcode build on. So yeah, you need to think about that and install the machines, connect them to the Jenkins and so on. Uh, Another one is a secret storage. So we have a lot of certificates, passwords, and so on that were used to sign the application, to distribute it, and so on. So we want to have a secure location, so that no developers have direct access to them, at least like after they were written once. So we need to deal with that on ourselves, like installing HashiCorp wall, doing the integrations, and so on. Another aspect is running tests. So of course you can just run unit tests, but for high bar of the quality, you need to run integration and end-to-end tests as well. And for that, you need the devices, you need to connect them to your Jenkins installation, you need to gather the test results, and so on and so on. So this is a manual work that we want to avoid. Also, we want to deploy our applications to the stores. So basically, we want to have the integrations in place that will push our binary thing to Google Play, to TestFlight, to Azure DevOps thing, or to other things in order to test it and ship it. So yeah, this is another piece of work. We also want to receive the notifications when the build is green or failed, and we want to know the reason for that. And basically, we want a very convenient tool for our development, not to spend like our time on the technical tasks, but rather doing what we do best, developing mobile applications. So cloud CI/CD tools kind of give us all of that, right? So they deal with hardware, they upgrade it, they make sure that the new versions of this code are already there, that the new hardware versions are there, and so on. They deal with secret storage, protecting your secrets, keys, and certificates. They can run tests for you, like connecting with the mobile farms. They obviously have all the integrations already written in order to deploy to the stores. They introduce the notifications to send you an email or an SMS or whatever, and basically they are very convenient to use. So we, as developers, as clients coming to those services, we have some kind of an expectations, right? So first of all, what we want are reproducibility, right? So uh, uh, we want to make sure that if we check out the same version of the code, the CI/CD pipeline will produce the same binary. And if there are errors, that the errors will be pretty much the same, so we can debug them locally, right? So we want the behavior of our CD pipeline to be reproducible and to be expected. Okay, next one is we want our pipeline to be secure, of course, because our mobile application is a very valuable asset of our businesses. So we want those applications to be secure, and we want our secrets not to leak anywhere, because like those secrets allow to replace the application in the App Store. So we expect a high level of security as well. And actually many more, right? So we want it to be convenient. We want to be not be very expensive. We want it to be accessible. We want the support of a high quality, and so on and so on. Okay. So from the perspective of those cloud CI/CD services, they really value their reputation. So they really want to be reliable, secure, and so on. Because if you hear about like a major security accident with some cloud CI/CD tool, you will move immediately, right? Because you don't want to risk your application. And the cloud CI/CD vendors actually realize that as well, and they put a lot of effort to be reliable, secure, available, and like be a good product, right? Uh, okay, so what do cloud providers do security-wise? They actually put a lot of effort in there. So first of all, they introduced the virtualization and containerization. And this is not only due to the security reasons, but due to the reproducibility reasons, right? So they start up a container and then they check out your code only in that particular container. And this container is disposable, right? They will throw it away after build succeeded. Your source code is not in danger anymore. And this is actually serves the purpose of separating the clients between each other, so they are not like building on the same machine. Like they do, but they're separated by containers and virtual machines, so they kind of protected from each other, and this is a very good thing. Another thing that cloud providers do, they put a lot of network controls and guards there, so they distinguish their networks, so there is no there are no intrusions there, so they put a lot of effort to monitor those networks, to have a proper access control, and so on and so on. Another thing is that if they store the artifacts in some kind of S3 buckets, they make sure that those S3 buckets have proper access policies, so nobody can write to them, and only limited amount of people can read them, and so on and so on. Another thing is that they apply airbag models, so the only minimum level of privileges is granted to the agents, like be it the developers or managers in the project, and so on and so on. So they really think about the security, and they really value their reputation, and thus the effort. And they do many more. However, we need to ask ourselves, are those security measures enough to protect our valuable mobile application? Because for many businesses, this application is the main product, the main thing that the client interact with. For example, you can pick up any neobank like Revolut or N26. Basically, they have only mobile application that you do all the work there. And if it's compromised, you essentially screwed. So there are many threats that I will briefly cover right now. So first one is reverse engineering and redistribution. Another one is a supply chain attacks, and I think I showed an example at the start of this talk. And intellectual property loss, and many more. So let's have a couple of examples. So first one is reverse engineering. So get back to this neobanking application. Imagine your application gets downloaded, reverse engineering, patched, and redistributed with another certificate via unofficial app stores. And it is really easy to trick the users into downloading the application through phishing. Like you just tell me, hey, the previous version was insecure, download this one, this is secure indeed. And then this patched application, it will just send the money not to the account that the actual user wanted to send it to, but to some malicious account. And your money is stolen, the reputation of the bank is corrupted, and you're in a very bad spot, right? So reverse engineering is really a problem. And aside of just redistributing with the malicious logic, we can at least review the logic. And there are examples of businesses that rely very heavily on the logic in themselves, like tax reporting applications. And there are a lot of a big part of the logic on the application. And if you easily reveal this logic, your competitors can come up with competitive product, and you will not feel very well as well. Another one, like app distribution, I already covered that. Chances are that you use some secrets in your application, they will be revealed through reverse engineering. Another example I want to show you is that a lot of people that are doing the mobile application with Xamarin, as it is the same ecosystem as Azure, they just put their Azure secrets right in the application. And then when they are reverse engineered, those secrets are easily accessible, and your data is screwed. So that's not great as well, right? Okay, another thing is the supply chain attacks, and another example I have is the Alamo Fire library that got corrupted in 2016, and it was allowing the man-in-the-middle attacks, basically. So it was bypassing the certificates check. So you could, easily place a server between the application and the server side and sniff all the traffic, replace the responses, and do whatever you like. So this is an example of supply and check, but because not the application itself was targeted, but rather the library's dependency was targeted and tampered with. So you should be aware of that as well. Yeah, infected defendants. And the last one, like there are many more, but the last one for today I want to speak about is intellectual property protection. And there are a lot of valuable assets in almost any application. So for example, company business logic that I already covered in the tax reporting application example, or media assets like music, videos, learning materials, images, artworks, and so on. You want to protect them, and you want to make sure that you really distribute to users that are at least paying for them, and not like for everyone, right, for the free access. Or machine learning models can be really pricey and expensive because you put a lot of effort of your machine learning engineers there. You came up with a model that really works for you, and it will be very sad if it gets stolen and reused in the application. So you want to protect them as well, and this is indeed a threat to your mobile application. Okay, so the question is like, how do we protect our application from all of that? Because the CI/CD security measures won't protect you from that. And the answer to this question is integrity, right? So you need to really check your application integrity. You need to make sure that it was not tampered with, it wasn't reverse engineered, and so on. And like the integrity is the key aspect of protecting the valuable application. Okay, so how do you do that? So first of all, you want to make the checksum, okay, but like just calculating the checksum of the application will not work very well for you, because like you can just redistribute it, or like repackage the application, recalculate the checksum, and like that's it. So you want to use the cryptographically ensured checksum, which uses the secret key that knows nobody aside of you. So like you will be able to check, and the malicious attacker will not be able to come up with a proper like cryptographic checksum. Another thing is the application and device assessment. So basically what you do, you ensure that your application is integral once it reaches the device, and you see if the device itself was not corrupted, like it doesn't have the root access, it doesn't have any malware, and so on and so on. And you monitor the application from the server side. You observe if the behavior is proper, or is it a strange one, and you like generally monitor the integrity, because like if the application or the device is not corrupted yet, like the next day it can become so, because user decided to root their device, like it got infected with malware, and so on and so on. So yeah. Yeah, there are a couple of other techniques like runtime memory protection, anti-dynamic protection, like protecting against FRIDA, against like dynamic analysis, and so on and so on. So there are plenty of tactics that you can apply here. Okay, so but those tactics are pretty complex. You really need to be an expert in mobile security to apply them properly. And that's why cloud app protection services exist in the first place, right? So they have some expertise. They can get your application. They can try to introduce the integrity in there, strengthen it, and like protect your app, right? So there are many examples like AirWatch, Mobile Iron, and other, like there's a list of them. So how this setup looks like altogether. So you have multiple CI/CD pipelines, then you have this app protection tool in the cloud somewhere else, and then you hand over the network this unprotected application and receive the rapid application back. And then once the application is protected, you try to deploy it to iTunes, to TestFlight, to Google Play, or to other services. However, this setup introduced a lot of threats, right? So first of all, what if traffic is sniffed? Then your unprotected application with unprotected logic will be leaked, and like all the threats that I talked previously will realize. Or man in the middle comes into place, replace the certificates, and like you're speaking not to the protection service, but some other service instead. Or malware infects the other side, and you're like not controlling the service, and you don't know what happens there. Or maybe there's supply supply chain attacks happens and like you're screwed again. And in order to avoid those threats, you really need a complex integration. So, for example, you need to apply VPN for this channel between the app protection service and the cloud CI/CD service. And you need to manage the keys, like you need to rotate the encryption keys and so on, because you want to encrypt your application and so on. Or maybe you want to introduce a SSL pinning. So there are a lot of things that you need to think of and like introduce as measures to protect this unprotected channel and handing over unprotected application over the network between the cloud CI/CD and the protection service. Okay, yeah, and don't forget about malware and supply chain attacks that can happen actually on the both sides, and like you need to put something against it. Okay, another aspect about this setup is that you can face the availability issue. So imagine you need to publish a new version of the application because of some regulation, right? That comes into force tomorrow, and you want to deploy the new version because you have it ready, and you hand over this version to the app protection service, but it's like unavailable. It gives you 500s. You reach out to support, ask for the when it will be available, and like nobody's answering. And like, what do? You release an unprotected application, then that's kind of risky. So yeah, this is a consideration regarding release management and so on. So yeah, not a very fun setup. So what I'm trying to say here is that combining the two services like Cloud CI/CD service and Cloud App Protection service introduces risks that are hard to deal with. So like you better avoid this setup. And what I recommend to do is the following. So please put all your like steps into the secure environment of your Cloud CI/CD provider, because as I already mentioned, they put a lot of effort to make it really secure. So have it all together. So starting with the Git checkout, then you proceed to the build, like with Gradle or Xcode build or whatever you use. Then you run some tests over that. Then you run some security checks and so on and so on, like vulnerability scans, security analysis, maybe some dynamic security testing, and so on and so on. And once you're good, you apply some tool that will be able to grant you the integrity of the application, to strengthen it, to fortify it, and to protect from those threats of redistribution, the like IP loss, and so on and so on. But please do it locally. Do it within the barrier of your cloud CI/CD tool. And only then, once the application is protected, you're free to deploy it to Google Play, to Test Flight, to Azure DevOps, or to whatever services you would like to use for testing or distributing your application. Okay, so what do you do on the Bitrise? So the good news is that on Bitrise, you have a lot of steps that allow you to do this. And those are verified. So like somebody looked at them and said, hey, they're good, they're safe. So there's Dex Protector by Litzel, there's AppRay mobile security, there's a codified security, and actually many more verified Bitrise steps that you can use to ensure the setup and protect your application. So what I'm telling you today, safe building, yeah, feel great about that, making sure you're using a good setup. If you like the article, I actually have a blog that is called vsalvage.dev, and I have a lot of articles regarding mobile security, mobile development in general, system design, software architecture, and so on. So you can subscribe there. You can join the Telegram chat where I put my architecture weekly newsletter, which includes mobile-related topics as well. And there's a YouTube channel where I speak about this newsletter and some aspects about software architecture. Those links will be in the speaker room, so I will drop them there. And if you really like the article, really like the content, there's a Patreon. Feel free to support the work I do. Thank you very much. That's it for today. I'm free to ask the questions if you have any.